In the last passage, which is the data passage, we are looking at carboxylic acids and propanoic acids, which have a different structure. They also have different properties, such as their electronegativity and also their acidity, so their pH. And we have some information in Table 1, Table 2, and then Figure 1 shows us the structure of different acids, acetic and propanoic acids. So our first question, based on Figure 1 and Table 2, which of the following is the structure for 2-iodopropanoic acid? Okay, well, it's a propanoic acid, and it's 2-iodo. So if we look here, 2-iodopropanoic acid, its X is hydrogen, and its Y is I. Okay, so what does that mean? If we look at Figure 2, we need to look at propanoic acids, and we have these two things, X and Y. So whatever they are in the table down here, that tells us what we should see there. So since our X is H and our Y is I, we should see H and then I here, which we do. These first two up here are acetic acids because we are missing the Y part. So 36 was J. For 37, based on Figures 1 and Table 2, the structure shown below has which of the following formulas? Okay, so since we have both an X and a Y here, this is a propanoic acid, and our X is Br, and our Y is hydrogen. So if we look at the table here, when we have an X of Br and a Y of H, this is our chemical formula, so we just got to match that to an answer. So the answer there was A. For 38, it says consider the structure below. Once again, this is another propanoic acid. Our X is I and our Y is Cl. Based on Figure 1, if the Ca or the other kind of acid with a structure we're listed in Table 2, the atom represented by X would be what? Well, X is an iodine atom, and so our answer there would be J. The question 39 was saying, according to Table 2, a 1.00 molar aqueous solution of which Ca, acetic acid or propanoic acid, is more acidic at 25 degrees Celsius. If you're more acidic, that means you have a lower pH. So if you look at Table 2, the lower pH out of the two is acetic acid. Right, acetic acid, we have a pH of 2.38 and propanoic acid of 2.44. Acetic acid has a lower pH, so it is more acidic. For number 40, fluorine is the most electronegative of all elements. Based on Tables 1 and 2, the pH of a 1 molar aqueous solution of fluoroacetic acid at 25 degrees Celsius would most likely be what? Okay, fluoroacetic acid is acetic acid with fluorine, and fluorine is the most electronegative of all the elements. So we need to think about how electronegativity affects pH. So if you look at the electronegativity of these atoms right here, what you notice is that the larger the electronegativity, the lower the pH. And since fluorine, which isn't in Table 1, but it tells us has the largest electronegativity, it would have a lower pH than anything that's in here. And the lowest pH was 1.44 out of all these acids right here. So it would be lower or less than 1.44 because since it's more electronegative, it has a lower pH. It's more acidic. So number 40 was F.